Now let's discuss LDAP concepts. We'll create a subsection here, labeling it LDAP concepts, where we'll discuss some of the important things regarding LDAP altogether, such as object classes, attributes, and the various types of object classes and attributes, and where you can find schema information, how LDAP interfaces with PAM as well as NSS, the name service switch mechanism, as well as just in general how LDAP interacts with the remainder of your system. Now, before we delve into some of the theory, we've prepared a couple graphics for you, and we want to take a look at them. So let's navigate to our home directory. We've placed them in our LDAP folder. We've got two graphic files here, including the notes file that is, with a backup file created by gedit automatically whenever the file is saved. And by double-clicking on either of these, we do see a supersized thumbnail version. We can then interact with what the hierarchy should look like. So there are two graphics. LDAP Edition 1 as well as 2, both are in your docs subdirectory on the DVD or within this particular release. Let's launch version 1 of the tree and discuss what applies to us in terms of LDAP concepts. Now, here's the directory information tree that we're interested in creating. We want to set up a top-level hierarchy. This is basically an Active Directory container object we've used from Microsoft Visio, so this represents the top of the hierarchy. Notice the terminology DC equals Linux CBT, comma DC equals internal, which is similar to the domain top-level name being linuxcbt.internal. From here, we will create 3 separate organizational units. We'll create one called People, one called Engineering, one called Sales. Now notice, for each of the subcontainers, the organizational unit subcontainers, let's focus in on People, for example. We'll just zoom in. Notice that the fully qualified or the distinguished name of the object is OU equal People, comma DC equals Linux CBT, comma DC equals internal. This is the distinguished name of this object, the folder or organizational unit object, represented by this picture which looks like a folder, which is open. So each LDAP object has a distinguished name. So concept 1, distinguished names, or DNs, or DN for distinguished name. Each LDAP object that is, has a distinguish or DN, a distinguished name. That name identifies the object distinctly from any other object anywhere else in the DIT, within the directory information tree. So each LDAP object has a DN within the DIT, the directory information tree, such that you're able to create multiple objects with similar names so long as their distinguished names are unique. For example, we can create a user in the People OU, naming the user Linux CBT, indicated below as UID equals Linux CBT. We may also create a similarly named user in the Engineering and Sales OUs, so long as they're not in the same OUs. That will be fine, and when one authenticates against the LDAP directory information server, which contains the DIT, the LDAP server will resolve the distinct user as presented by the client. So long as you maintain users in different OUs, they can have the same names, which is one of the flexibility of having this hierarchical layout. In a flat layout, such as an etc password, you cannot maintain 2 users named Linux CBT. So we should just note that. This facilitates a hierarchy which allows duplicate names in unique containers. So long as those IDs, those objects that is, are in unique containers, you should have no trouble whatsoever. So back to the graphic for a second. We're going to be creating this directory information tree, and it will contain 3 organizational units represented by the yellow folders towards the top of the graphic, and they will be people, engineering, and sales, which are all sub-objects of the top-level domain. Now, each of these object types have or are of a specific object class. An object class defines a type of attribute. So let's just go back to our notes for a moment. Another concept is an object class. We've kind of jumped the gun by discussing distinguished names, because distinguished names are derived from the object class and the name within a given portion of your directory information tree. So object class or classes define the type of attribute, and they are also instances of a schema group. So for example, looking at our graphic, the organizational unit folder for the OU people is an instance of an organizational unit. That is a type of object class. So instances of a schema group, and we'll just, for example, list IE OU equals people is an instance of organizational unit group or schema group. And many such instances can be created throughout your directory information tree. So basically what this means is we derive our object classes from the schemas that are associated with the LDAP server. Now you may be wondering, taking it one step higher, where do these schemas live? Where do they come from? Who defines them? What's in them? So on and so forth. So yet another concept to keep in your mind is the fact that there are schemas. And those schemas live in the default etc OpenLDAP schema subdirectory, which we'll be looking at momentarily. So let's just recap what we've discussed so far. LDAP has the following concepts, non-inclusive lists of concepts. Distinguished names. This is something to get used to. Every object within the directory information tree has a unique ID. If you try to add objects that have duplicate or the same ID, an error will be returned by whatever utility you're using, whether GUI or text-based. So each object can be referenced uniquely. That is called a distinguished name, a DN. There are different types of object classes, and an object class defines a type of attribute, and it also is an instance of a schema group, such as an organizational unit. There are also schemas, which are located in etc OpenLDAP schema, and they define the types of object classes that are supported. Now, there are many other types of object classes, such as the domain, the top level of the hierarchy, a user, for example. These are all object classes of some form or another. So in addition to organizational unit, we'll list DC equals object class for the top level domain. In our case, that's going to be DC equals Linux CBT, DC equals internal. And within the schema configuration of your LDAP server is a definition for the DC object class, just as there is a definition for the DC organizational unit. So there are many types of objects that we can instantiate by using the text as well as and or GUI-based tools that are LDAP compliant. And the object classes, again, are defined in the schemas. Now, we did mention we'd take a brief look at the directory. You don't need any special rights, so we can do so as the user Linux CBT. We'll navigate into etc OpenLDAP schema, and in this directory we see many files for different types of programs, such as for the antivirus suite and others. But among them live a core set of schemas, including core.schema, corba.schema, etc. These schemas are included with the LDAP distribution, Open LDAP distribution. If you're using a proprietary LDAP implementation, more than likely it includes, on top of some of these base schemas, proprietary schemas to support other attributes that are considered non-standard. So core, Corba, inet.org person, from which we can define users and attributes pertaining to those users, such as address, phone number, building, cell phone number or mobile number, so on and so forth. An Open LDAP schema, one for Samba, a Java schema, cosine schema. All of these are included. Everything you see within etc Open LDAP schema are included with this distribution and are considered to be the core set of schema files which define the attributes and object classes that are permissible for that given schema. Now, objects within an LDAP directory information tree can inherit attributes from one or more schemas. So let's just note, schemas define the object classes and supported, or we should indicate this as define the supported object classes and schemas. These are the schema files. And another way to say schema would be, of course, the set of attributes. A schema is a set of attributes. So the schema tells LDAP the supported object classes for the given schema and the supported attributes. Think of attributes as fields, and the object class is the type of object which consists of one or more attributes, usually more than one attributes. So note, object class consists of one or more attributes, and note, attributes are fields, just like in a database. So this is how you can think of the relationship between a schema, an object class, and attributes. Schema consists of the permissible object classes and attributes. So note, schema defines the permissible object classes and attributes. So the schema is the driving force, just like within a relational database. So to quickly recap, we've got distinguished names which uniquely identify objects within a directory information tree. Every object has a unique DN. Looking at the graphic again, the top level domain has a DN of DC equals Linux CBT, DC equals internal. The organizational unit people has a DN of OU equals people, DC equals Linux CBT, DC equals internal. And let's jump to the user in the sales OU. This user who will create has a distinguished name of GID equals, this is a group, so let's look at the user, UID equals Linux CBT, OU equals sales, DC equals Linux CBT, DC equals internal. So indeed, it's a hierarchy, which is what is provided by LDAP. Every object, distinguished names. There are object classes, and object classes define the type of attribute, such as a domain object class represented using the DC indicator. And object classes are instances of a schema group, such as an organizational unit, or again, a domain. It's simply an instantiation of the attributes defined within a schema, which constitutes an object class. And a schema, of course, contains everything. It defines the permitted or permissible object classes, their attributes, and so on. And all of this is done to allow us to create a hierarchical depiction of our data. With hierarchy, we can support what seems to be redundancy within a flat file, such as two users with the same name or two groups with the same name, and so on. Now just a quick word about attributes. We know they're fields. So these are basically fields. Fields such as first name, last name, address, phone number, etc. But in addition to being plain old fields, attributes may or may not support single or multiple values. They at least support one value, and they may optionally support multiple values, depending on the schema. So supports single/multi depending values depending on the schema definition. So you may find a field which supports, or an attribute which supports, multiple values. But again, an attribute is a field. It stores values like variables in a scripting language. So let's just note that attributes store values like variables in scripting/programming languages, such as variable name equals value, or variable name equals a list of values, as we have with arrays. So think of attributes as scalar and or arrays in a scripting/programming environment. Now let's give you another example. In the case of DC equals Linux CBT, comma DC equals internal, DC defines, in this case, DC colon Linux CBT defines the attribute naming the domain. Now granted, it's used twice, so in this case DC can be considered to store multiple values, because we generally reference DC as the following: DC equals the suffix, comma DC equals the absolute top level of the domain, such as internal. So that's an example of an attribute. DC equals, again, Linux CBT, comma DC equals internal. Multiple values are stored. Another example of an attribute, for example, the UID Linux equals Linux CBT, OU equals people, DC equals Linux CBT, DC equals internal. All of these values constitute the DN attribute, or distinguished name attribute. So this is a one-to-many attribute. So i.e. DN equals UID equals Linux CBT, or DN colon, we don't use equal twice, UID equals Linux CBT, OU equals people, DC equals Linux CBT, DC equals internal. All of this constitutes an attribute named DN. So this one attribute represents multiple values to uniquely find the user Linux CBT in the people OU versus the user Linux CBT in the engineering organizational unit. Another example of an attribute that you'll find in the primary configuration file is rootDN. You'll find this attribute in etc openLDAP, once we have it set up, slapd.conf. This is the primary configuration file. Well, rootDN is the name of the user who is allowed to write to the DIT. Name of user allowed to write to the DIT, unless you alter the permissions, the LDAP permissions, to permit writing by a group or another user, and or another user. So rootDN is yet another example of an attribute which references a unique user, which is usually the user named manager, within your directory information tree. So when you authenticate to the LDAP server using the rootDN attribute, which expands to the credential, the user credential of that particular user, which means username and password, which fully expands to UID, which is manager, the DC, which is Linux CBT, and again the DC, which is internal, that user has full write access to the domain. And you'll see as we add, modify, and remove items from the directory information tree that will consistently authenticate using the LDAP tools, whether GUI or text, as the rootDN attribute. Again, this attribute defaults to manager. Let's just note rootDN defaults to the following. CN for common name. Common name is, again, another attribute type, but again, we can have these one-to-many relationships where one attribute name, such as rootdn, references multiple attribute names, such as CN equals manager, DC equals Linux CBT, DC equals internal. So this will be our default root user, referenced by the rootdn, which we define in the slapd.conf general configuration file. So those are some of the concepts concerning LDAP. Again, without getting too deep into how the schema works, how it's laid out, so on and so forth, that's separate subject material in terms of defining and modifying schemas, we've got these base concepts. Distinguish names. Just always think to yourself that in LDAP, every object needs to be uniquely identifiable. There are object classes, instantiations of schema groups such as the domain and other items, organizational units, to name only a couple. There are schemas, which are included, and they're located in etc open LDAP schema, such as the core schema, INET org person schema, which supports storing additional information about a user. And there are attributes, which are basically fields, and attributes can have one or more values. And we've given you examples of attributes, such as DC equals Linux CBT, comma, DC equals internal. In this case, DC is being used twice, so the schema permits multiple values to be stored for DC. But when you put it all together, uniquely spells out DC equals Linux CBT, comma, DC equals internal, analogous to Linux CBT.internal in the DNS world. DN is another type of attribute, which is one-to-many. Its name is DN, distinguished name, but it references uniquely in the tree a given user, or OU, or group, or some other type of object. Rootdn is another attribute, defined in the main configuration file located beneath etc open LDAP slapd.conf. This is the name of the user, the super user of the directory information tree, the user who authenticates to the LDAP server and is allowed to make changes to the directory information tree. Now, we still have more concepts to discuss, although we've yet to set anything up. Another notion is how LDAP interacts with PAM within a Unix or Linux environment. Now, PAM authenticates users on behalf of a calling application such as SSH, Telnet, the login program, so on and so forth. PAM is short for Pluggable Authentication Modules, and again, it authenticates users on behalf of calling application. So with that said, PAM supports LDAP, which means when our systems are configured to authenticate using LDAP, when we log in through a program such as SSH in a properly configured environment, SSH calls PAM, PAM calls LDAP in a properly configured environment. Now, just in case you're wondering how this is all woven together, there's another component, and that's the name service switch component. NSS, which on Unix and Linux systems is configurable via etc nsswitch.conf. NSS is used by applications to find common Unix databases, such as etc password, etc services, etc protocols, and on and on and on. Let's just name a few. etc is a prefix, and in between curly braces, password, shadow, where passwords are actually stored on a secure system, group for a list of groups, hosts, services, protocols, etc. This is just a short list of files or tables that the name service switch consults when asked to do so by a calling application. Now, how does this all come together? Well, basically, both PAM and NSS work in conjunction to authenticate using LDAP. So let's just list as a seventh concept, both PAM and NSS are in cahoots. They work in conjunction to authenticate, and by authenticate we mean to determine whether or not a given credential set is allowed to access a resource using LDAP. And this is configurable via etc/ldap.conf, whether or not LDAP will make use of NSS, which within a SUSE environment, the YAST application takes care of for us. Now we've got a second graphic which illustrates how this works. The first graphic just gives us the basic DIT that we'll create. This will become our DIT. But let's open yet another graphic, the second graphic. We'll maximize it and move this on the right. So here's an extended layout, an expanded layout of what we've already discussed. So we've still got the directory information tree indicated by this Active Directory icon that we took from Visio for Linux CBT internal, and its sub-containers, which are basically organizational units which contain users and or groups. However, if you think about your server as a provider of services such as SSH, FTP, and others, Apache, etc., we connect to the program from local or external means. So we may be on a remote system and SSH into the system that's configured to use SSH in conjunction with PAM, NSS, and LDAP. Or we may FTP into the system and ditto. So if we SSH into the system, I like to use SSH because it is the more obvious of the two protocols as to how this all works. So you are connected to your local system and you SSH to a remote system that has been properly configured to use LDAP. The SSH program running on the remote system consults PAM, pluggable authentication modules, to determine whether or not the credentials being supplied are credentials that are permitted to access the server. PAM consults NSS, the name service switch engine, to determine, and it's a library, it's a C library, to determine the ultimate lookup location to compare the supplied credentials to. So NSS determines whether or not to consult etc password versus LDAP, or both. So supposing we log in without LDAP configured using SSH or FTP, PAM is consulted, NSS is consulted, and the default configuration consults etc password. In etc password, PAM expects to find via NSS the user who has been supplied, or the credential set that has been supplied by the calling application, such as a request to authenticate as a user named Linux CBT. And of course, if an error is returned, then the user is not allowed to authenticate. Now again, before we configure anything, if we take a brief look at the current configuration of our remote system, we'll SSH over to our remote SUSE system. We'll be working on a couple systems, few systems here. And then we'll navigate into etc and take a brief look at the NSS switch.conf file. We see that on the remote system, when NSS needs to determine an item from that requires a lookup in the password file, it's set to compatibility mode, which means it consults the local etc password file, not LDAP. Ditto for group, and for hosts, for resolving hosts, we consult the local hosts file first and DNS. And these are the various tables that can eventually be merged or migrated over to LDAP. But the most important is the password specifier, PASSWD. When set to compatibility or files, NSS will route PAM to the local etc password file. So again, we try to SSH in, PAM calls NSS, NSS knows to go to etc password because it sees compat or files listed. But when LDAP is properly set up, this entry will reflect that NSS is to consult both files and LDAP. So what that means is if NSS is unable to locate a user in one repository, such as etc password, it will then move on and check another repository, such as LDAP. So that's how you want to think about the relationship between a given application, PAM, and NSS. Applications are written to consult PAM, at least modern applications are, whether it be Apache, FTP, SSH, Telnet, Login, etc. They consult PAM. PAM consults NSS, the name service switch. NSS determines whether or not to consult LDAP and or etc password. Now, it's always a good idea if you're going to configure LDAP, regardless of your server, AIX, HP Unix, Solaris, Linux, it's always a good idea to configure your services to consult both etc password and LDAP. You shouldn't leave out etc password in the event that LDAP is down, because then you'll be unable to log into your machine while it's up and running in multi-user mode. So keep that in mind. So with that said, we've discussed some of the key LDAP concepts. Again, we've been talking theory and features for the past 2 lessons, and we want to move into actually configuring the server in the next section. So what we'll do is we're going to set up our SUSE box as the primary LDAP server. And then once we have it up and running and we've created some objects and played with some of the tools, we'll make the configuration replicate to the other systems in our environment, including Solaris as well as Red Hat Linux.